So our next panel is Cryptography's Best Move. We have moderator Joshua Tobkin, and I'd like to invite everyone up to the stage, Josh, Kostas, and Dr. Kate, and I'll let Josh take it off and intro everyone personally.
All right, I hope my audio is coming through. That was a great panel, Cheyenne. Thank you so much. As we all know, MoveLang is very promising. Of course, we have Solidity, we have Rust, but kind of the new kid on the block is the MoveLang, and there's so many promising things. As the folks that are into Move know, that this is a much safer smart contract language, much easier for developers to not make mistakes, right? So, and that's really important for the industry in order for us to kind of move forward. So my name is Joshua Tobkin. I'm the co-founder and CEO of SupraOracles. I have the absolute pleasure to introduce two absolute gigabrains, Dr. Kostas Kryptos of Mysten Labs, and the Super Zone, Dr. Aniket Kate. So let me do some quick introductions and we'll get started here. So Kostas is an applied cryptographer, having led the crypto and security teams of at least 3 blockchains: R3 Coda, Facebook's or Meta's Libra project, and now Sui as a co-founder of Mysten Labs. His work expands in ZKPs, time capsule encryption, solvency proofs, and optimized BLS, ED, DFA signatures, occasionally a white hat hacker, having found serious vulnerabilities in many crypto systems and smart contracts in the past. Dr. Aniket Kate brings 15 years of research experience in applied cryptography, distributed systems, and digital privacy at Supra. He has been actively working on blockchains for the last 10 years. His high-impact projects include KZG polynomial commitments. In the Ethereum world, you all might know KZG commitments or Kate commitments. That was Dr. Kate's invention. He's also involved in partially synchronous DKG, distributed key generation, layer 1, layer 2 transaction privacy, and of course, randomness by distributed oracles. So welcome to the MoveCon. This is a very exciting opportunity for me personally. I do get a wonderful chance to work with Dr. Kate closely, but I've been following with Kostas, or we also like to call him Kryptos, his work as well, and it's a wonderful time to be here. So let's jump into this. We have some really wonderful questions to jump into this first, and the first one we have is, what is the current status of cryptography for blockchain? Where are we as a community, and what are the most interesting primitives from your points of view? Maybe we can start with Kostas.
Yeah, thanks for the introduction, Joshua, and good to see you again, Aniket. By the way, we had this discussion like on the very early days, like after Bitcoin. Imagine we started just with a signature. You need the signature protocol and you need the hash function, of course. But then down the road, we realized after 2016, especially after like the Ethereum smart contract language coming there, and some permission blockchains originally from IPM, like the Corda one that I worked like originally, and then all of them like L1s, L2s popping up into like offering some new features. What changed completely was even the career path of a cryptographer. Like I remember most of us actually started with PhDs and everything. Probably our best option was to be like probably an academic somewhere, right? And we didn't have many options. However, we realized that it's not only signatures and hash functions, right? Imagine we have Aniket here who created a new kind of accumulation, right? And previously we only knew about Merkle trees. And then out of a sudden, suddenly we found like a way to have all one commitments, like you just push one single piece of data, and then eventually you can verify that something is included in some group, like a membership proof, which is very, very fast. This is very useful, right? So we have new commitment schemes and new accumulator schemes that are very important for many operations in the blockchain. I will leave this topic to Aniket, and then I can get back the past to talk about zero knowledge proofs and other quick information that you might want to know. Aniket, I leave this topic for you because you are the expert here, right? The inventor of all of this cool technology.
Thank you. Yeah, so I guess I did not prepare to talk about that. Just kidding. So indeed, I guess what we started to observe that it is possible, especially for the proof from the proof perspective, the knowledge proof perspective, that we can make them extremely succinct and still try to maintain the universality in different approach. And there's a significant growth that happening in this space. So I can certainly say that the zero knowledge proofs are prevalent and are continue to remain prevalent. It's certainly a major shift in last 2 to 3 years that we started to see a huge effort that happening there. And indeed, KZG is one part of it, but there's a huge effort that happening in all sort of different mechanisms that could be applicable and employed there. And in fact, you can say that there are every 6 months we have a new cool kid on the horizon. And not only they just have theoretical, people already go ahead and implement it. So it's very nice. And also when I hear from Kostas that they are always upfront on that and they want to make sure that that's available with the Sui move, it's certainly the extremely win-win situation, because rather than relying on some off-chain mechanisms, you can just do that at the layer 1 itself. Along with that, I want to add a couple more things. Moving forward more is that from the perspective going forward, I guess the multi-party computation, threshold cryptography, as well as things such as VDF or verifiable delay functions kind of technologies could also have very interesting impact on some of the solutions that we're working on. But indeed, as Kostas already mentioned, zero-knowledge proofs are certainly something the most exciting talk these days. Yeah, Kostas.
Exactly, and it's not only zero-knowledge proofs, right? I mean, you mentioned threshold cryptography now, and at the same time, we have like all of these requirements, especially on the wallet side, where people want to share their secrets to different parties. And then again, you need some MPC, you need some threshold cryptography as well. So we have zero-knowledge proofs. We have obviously like optimizations on the signature schemes. We have very fast hash functions. Some of them have to be zero-knowledge proof friendly, because the hash function is everywhere, right? It's not only the conventional functions we know, like SHA-2, SHA-3, make Blake, but there are also like Pedersen hashes. There are like Poseidon. There is like the rescue hash function. There are many new hash functions happening in the space that are very useful. And at the same time, I will add a few more like concrete applications that might use in the background, like MPC or zero-knowledge proofs. It's anonymous credentials, right? It's very, very important, like primitive for especially KYC, and regulation is coming, and we will see a lot of cases where the anonymous credentials are very important. Inside these, there is like development in cryptography to have like some kind of trapdoor in case of an investigation. There are some situations where you have to like combine this with like some tracing if something bad happens on chain, and then you need to find who is actually responsible for some fraud happening. And at the same time, there is also a very interesting topic that we will discuss today, randomness on the blockchain, right? It's something that we will see coming more and more, especially with a protocol like Sui, that we actually advertise all of these high frequency blockchain transactions per second, and at the same time very, very low latency. Having like a method to provide randomness very quickly to all of these gaming applications that will probably jump into one of these high frequency blockchains is one, like, you need to create new protocols here to be able to accommodate all of this traffic and requirements, right? And there is more under this, right? There is also like a part of cryptography that is like focusing VTF, you mentioned verifiable delayed functions, that can also be used for randomness, by the way, apart from all of the other things that we do. And there is also cool technology like using all of these primitives for e-voting. E-voting relies a lot on some cryptographic primitives. There is also sealed bit auctions. And with auctions, we can even have like time capsule encryption and all of these like schemes that you didn't expect that they even exist, but the blockchain make them a reality. And I can give you some hints in the past. Before the blockchain space, I used to work like with governments and actually even advising a few operators out there. They didn't even expect there will be like down the future some like public bulletin board where all of these functions, either by oracles like the SupraOracles or by the L1 like blockchains, will be available for non-technical people. And this is, I think, the bet we had in the last few years. The blockchain helped a lot on the evolution of cryptography in general. And I believe this is because there was a new ecosystem of startups. Obviously, the money was flowing much easier for innovation. And this was an obstacle in the past. Imagine that in the past, it was only NSA and NIST providing new standards into the space, right? And now we have community proposing new schemes, and then people are betting, are actually making auctions, are voting over the next standard, which makes decentralization even better and the proposition of new ideas a lot easier now.
Yeah, thank you for that, Kostas. So we just talked about some very interesting novel use cases that this technology can enable, from privacy preserving credentials, things like DIDs or verifiable credentials that might be required in order to access, for example, peer-to-peer decentralized, but regulated in KYC liquidity pools, for example, right? Which probably will expand the pie actually, right? Like or not. So what I'd like to talk about briefly here is, instead of like, I want to talk about the future and where we're headed, but let's talk about what are some of the limitations of legacy blockchains today, and what does Move bring to the table to enable these new capabilities?
I can start, Aniket, if you want, and then I can give you pass here, right? Okay, cool. So as you know, I've been involved in 3 blockchains, and at least I broke a couple of like smart contracts in the past. And I know for sure what was like one of the mistakes that we did and what are the lessons learned down the road. The first thing is, many of the primitives originally, especially like on the very early days of Ethereum, were just like a signature verification and a hash function. And then for more complex applications, you had to rely on some developers, like writing on Solidity and now in Move, but I will explain what tricks we did in Move to accommodate this. They had to implement their own algorithms in a very like constrained programming environment, because you have to pay gas for all of these things. Sometimes you might not optimize it specifically for the smart contract language. And what we did in Move is we got some of the most interesting primitives and we put it as like L1 supported natively functionality. And this is very important, because even now in Ethereum, you have to rely in some particular cases in like third parties just to have zero knowledge proofs, right? And because, I mean, people are not familiar with all of the complexity that this entails, right? And what we did is we enabled a zero knowledge proof verifier in Move. So we have growth 16 and people can now do growth 16. And in the future, we made it agile enough so people can come and bring more functionality into the the verification stage. Typically on the blockchain, what do you need, right? You need verification. All of the signing, proving, sometimes even the extraction of randomness is happening off-chain. But what you need to actually include as functionality internally is a very simple API for these things to be verified, right? This is what you want. And typically it's deterministic function. And that's why we don't have secrets on the blockchain, flowing secret, which means that you don't literally sign in a smart contract. You sign off-chain and you send the signature as a verification on the blockchain. And now that I mentioned signatures, then I realized, oh, we have all of these systems that like typically in the past, they only support one signature algorithm. And then if you go and see what the backing sector is using, like some old HSMs, or what are the mobile devices using internally in the secure enclave, oh, they use ECDSA still. And they sometimes use not the K1 curve that is used on the Bitcoin, but they're using the NIST curve, like the one blessed by the agency of the United States, right? And then what we did is crypto agility there. We allowed 3 signatures that we believe are the most common in the space to have compatibility with everything. The ECDSA K1, so a Bitcoin or an Ethereum developer, along with support of Ketzak hash function, they can literally have Ethereum signatures being verified in Sui. So we took into account bridging as well. And bridging is very important, right? Because if you know Sui Move has this support, SupraOracles can probably be a bridging provider in the future by having easier creating a system that can verify this kind of signatures both in Ethereum and in Sui, and they don't have every single time to reinvent the wheel and implement a new signature algorithm. At the same time, it gives the ability to people to create new multi-sig schemes where someone might say, okay, I will use a mnemonic, but at the same time, I want my iPhone literally on the secure enclave to sign a transaction. I don't even know the secret there as a 2FA. So allowing a larger set than previously of signature schemes enables Sui some agility and some new perspective of how you can do authorization of transactions or even bridging functionality from other blockchains that wasn't like the case before. Now to do some bridging, you have to go through other systems like IPC or like Cosmos and other situations. While in Sui, we have this embedded into the the protocol, BL1. The other thing is we allowed BLS verification. And I know that BLS is also very important for you, right? For Oracle, for SupraOracles, pretty much all of the Oracle system, because BLS is a very, very a useful system due to aggregation. Eventually, we're ending up into a very compressed output. And now someone can use it not only for signature verification, they can even use it for randomness verification. They can even use it for timed release verification, for identity-based encryption verification. So by allowing extra primitives that you didn't have before, we believe that in Sui it's easier for the average developer to just go and say zero knowledge proof.verify, SupraOracles random beacon.verify, right? You don't need to actually implement all of the functionality to be supporting all of the other features that are existing in other blockchains as third-party development. So we're working into this stuff, so we have as much as cryptability as possible. We even support ECVRF, for example, in Move, and you can even see like bulletproof scamming and some other systems like are next to the door at the moment. And yeah, I mean, you have also experience in other blockchains, and you can even tell us, right? I mean, Aniket, if you want something to exist on Sui, let me know, right? What do you want to have here?
Yeah, and so indeed, I guess let me start from that point. Indeed, the capabilities that are incorporated in Move, especially with the Sui, are quite tremendous. In fact, let me start with a bit controversial, funny statement. Maybe with all these capabilities available, the idea that you're taking away the jobs, taking jobs away from cryptographers, from the traditional system. And let me elaborate that from an example in a way, right? The idea is that let's say I build a current solution which involves some cryptography today in a traditional blockchain environment. There, the key thing is always ability to get some property in system of Bitcoin and the gas cost and latency of something like Ethereum and other systems like that. And what can happen that tomorrow with a minor update, somebody might be able to make it a bit more faster or more importantly, more gas efficient, and you're stuck. You'll all of a sudden, that's what matters. But and that certainly, it actually in a way facilitated good research perspective to bring a specialized smart contract which can make it work tailored. Like, oh, this operation costs this much gas and this other operation this much cost, so I'll try to combine them in a fashion to save the gas. But they are artificial in a way because those are the gas costs that are decided on the system. And it's not that I can take that exact same solution and make it work elsewhere. On another system, it will be completely different ball game, and a solution in one system may not remain applicable in another system, and I have to start from scratch. So I have my job. Coming back to job. However, if you have capabilities like that are inherently available by blockchain level itself, then it becomes much more easy. You are much less vulnerable for the easily getting scooped by somebody who just make some delta modification, because all these things are there and also cost effective, cheap, and also at the same time there's no latency issue in most environments. So that do make all these things very easy, where you build something where development is easy, because you don't need, as long as you understand the input and output behavior of such system, you can build your protocol efficiently without worrying about cryptographic knowledge or having cryptographic capability. So that is a huge tool and extremely important thing to work, because many environment, even today, when we try to work, like let's say, just to give example, scriptless script, if people in the audience have heard about in the Bitcoin context, they're interesting technically. It's a very interesting thing. It's nice for us to work on the black, but to implement those is a significant challenge, because there could be significant off-chain component to ensure the security. What on-chain cryptography can allow is to make these things easy and less error prone, because now everything is already worked upon. So that I certainly see as a really important direction that will emerge as more and more cryptography is available. And actually, I want to add indeed there that because is adding those many options there, that will also force even others to consider that, and which is an extremely huge win, because that will indeed make many things solvable directly at layer 1. And if we have efficient layer 1, why to even go for layer 2? So that makes everything very easy. So building application can become easy and also less error prone. So that you don't need to go through hundreds of audits, like you require a special audit for smart contract, special cryptographic protocol, another for distributed system protocol, and maybe fourth one for game theoretic aspect. So all those things become extremely difficult. If you may be saving significant time and energy as well as cost by having on-chain access to all sort of different things.
And I will add, Aniket, that a tendency that I personally see is when you provide like to the developers some like a rich cryptographic API, they typically try to build even something that was not possible in other blockchains. Because if you have the primitives and you spend your time, as you said, less on introducing this primitive into the blockchain, now imagine automatically as like an individual, you believe this is a piece of a puzzle, and then you can go and build a bigger puzzle, like a more complex solution that previously you had to implement all of the primitives for this complex solution, combine them like this composability thing that Sui is also offering, which is super useful, right? You can even have an auction like contract, and then along with the composability of Sui plus the primitives of cryptography, you can extend the auction like contract into something else now. And this gives all of this like clarity, because we're a strict type as well. It's not like Ethereum, a random U256 number. It's an object ID and you can see the type, right? And along with this, plus cryptography, I believe, and I see it already, that some people are building more complex construction that previously was not able to be done either for gas cost, because now all of the primitives are optimized, right? While if you do by yourself, and especially in a new language like Move, people wouldn't be so writing optimized code. And we did it for them to increase the adoption of like a new language into the the system.
That's great. Yeah. So, traditional blockchains are kind of like, they only kind of speak one language, right? But the introduction of this framework allows, and kind of blockchains of the future are going to be almost like multilingual. Like they'll be able to, different signing algorithms are not necessarily compatible, but if you're able to kind of enshrine this from the get-go, it's going to unlock a lot of capabilities. Okay, great. So one major use case that you touched upon has to do with like gaming, right? So high throughput, low latency, and also low gas fees. Dr. Kate kind of mentioned gas as a major component, and a lot of people don't talk about it. Very under discussed, because especially for more expensive like chains like Ethereum, the gas cost becomes an economic barrier. So using novel cryptography, we can actually have more gas efficient economies of scale, X, Y, and Z. And we at Supra pay a lot of attention to that. But one conversation about I would love to kind of talk about randomness on chain. So GameFi games are going to be, in my personal opinion, one of those major unlocks to bring a lot of people into the blockchain ecosystem, many of which initially will not even realize they're using a blockchain. But to have great gameplay, we need low latency, we need efficient gas costs, and we need on-chain randomness. So most blockchains are very orderly, deterministic, and therefore actually lack randomness. Let's talk about this topic for a second. Why is on-chain randomness difficult, and what are the most promising approaches? Maybe we can start with Dr. Kate, and then Dr.
He's the expert. He's the expert on this. I totally agree.
You're both experts, I'm sure. Guaranteed.
Yeah, thanks. So no, it's a very important question. Actually, I want to make a confession here. Initially, I thought this will be an easy problem, but more and more time I spent here, I see that I can easily see so many combinations and a lot of headache to deal with. Let me put it this way, simply. So first of all, let me start with the on-chain randomness could be thought of as having some kind of entropy on blockchain, and it's hard. The initial thought was possibly we can use block hash as a mechanism to have some kind of a randomness and use it. But it's in almost all environment universally, it is certainly something that decided by the proposer of the block or the miners or the validator in some way, and they have a say, so they can easily bias it. They may not be able to bias it completely in some environment, in some environment they can. However, they can easily make it biased. They can always make sure that let's make some bits zeros or some bits one by appropriately selecting some transition orders. And in many examples, as we use randomness, we might be only using few bits of entropy, and they will be able to control that easily. So if you don't have any access to any good randomness, block hash is a good starting point, but it's certainly not useful once you have any kind of a environment available where you want much better like unbiasability and unpredictability property associated with your random. And to add into that, then the idea will be that typically approach towards getting such randomness is to use concept from the distributed cryptography, such as verifiable random function. I want to add there one aspect which was also somewhat less appreciated before blockchain, and that is the concept of public verifiability. games today, in my understanding, want public verifiability, that they want to prove that not only they are using randomness that is provided by services which are creating that, following cryptographic standards and as well as provably secure protocols, but they also want to make sure it's publicly verifiable so that their current players as well as their new players or their potential future players can verify that correct. And that adds another interesting feature that typically, along with the unbiasability and unpredictability that you want. The reason why I think that initially I thought it's easy, but it's hard, is that once we have mechanisms in place where we are using this randomness for different game purpose, where there's the game owners and the players and dynamic between them, these properties could be not trusting each other well. That introduces several interesting combinations, and in terms of how to employ these random functions effectively and efficiently using any blockchain environment remains to be an interesting challenge. In fact, what we are looking into is that we have to characterize game, understand the game, their needs, and correspondingly decide how should this be built. And if this game has to employ mechanisms where gas cost is going to play the role, we have to see how can we save the gas cost, and also at the same time latency is the issue. If we are accessing these randomness services and it's going to take just 10 minutes to just get access to the randomness, it may be too late. They may not be able to keep the users interested for that long duration. So making sure that the latency that gets introduced with the existence of blockchain added for accounting and public verifiability should not affect the speed of the game is certainly one of the interesting challenges in this space. So coming back to the thing is that, employing random beacon protocols and verifiable random functions are interesting approaches towards improving and adding entropy to the blockchain environment and through that the games. However, making sure that the latency is low and the protocols are gas cost are efficient in terms of the gas cost is a challenge that has to be looked into and carefully understand.
I totally agree, and I will add on this on the business side because, as a co-founder, I can see what's happening on the gaming industry. There are situations, for example, in Asia, like gacha loot box and some other types of games are so popular that, and also by culture, some folks in different countries are very sensitive on the verifiability. That I believe these systems should be standard around this verifiable randomness, and obviously we need to find a way that people are convinced about how it's happening. I remember very recently I had a tweet, why no country until now hasn't used a verifiable public randomness even for the lottery, the national lottery and everything, right? Because people always have question marks in the back of their mind. There are many ways to cheat in this situation, especially if there is a physical ping-pong ball like randomness. And now we have blockchains. And I remember answering this question even on front of regulators, that in some particular situation, the blockchain is offering for the first time a public ledger where, along with the verifiability of the randomness, it's the only way to ensure that nobody is cheating. And this is super useful as a functionality that is offered by Web3, right? And I believe we say gamings now. I can see in the future how bigger, even statistical sampling and other things that they have to be verifiable, even from IRS, right? They should happen with this kind of technology, like verifiable randomness, with many committee members offering some entropy into the system. Maybe VDFs, maybe we can even use the oracles to give, the closing prices of the stock market at the second decimal digit. And then there is an extra source of entropy into the system, right? And I believe, apart from gaming, we will see major, even governmental operations requiring this kind of functionality, distributed randomness.
Yeah, I also agree that it's about time. There's probably, actually, I come from a gaming background. My first startup 15 years ago was in the gaming background. And I used to complain always to my partner that I don't feel like this data is correct. I don't know if I can trust the system, but I had no recourse. There's no public verifiability. You can easily imagine some startup out there, it won't be us, but that will use DeFi primitives like peer-to-peer pooling of funds, and then using some sort of verifiable random function to do a global lottery, right? And that could be massive. Let's move on though. It's a very interesting topic, but we have a couple more very, very interesting topics. And one question in particular that is hot right now, and it has been kind of discussed, especially with the collapse of decentralized exchanges, is proof of reserves. And of course, the other component of proof of reserves, right? It's like, okay, sure, I can show you that there's money there, but how do I know that what the liabilities are, right? So let's basically, what are some of the cryptographic techniques that we can enable proof of reserves and liabilities?
Dr. Kate, if I can get this one. This is my topic, actually. I try to do all of this work at Facebook, at Meta, right? Imagine Meta tried to be as like friendly to the regulators as possible. I mean, literally offering whatever is possible. And then we extend it when I joined Mysten. And we even get like interns that are working on this particular topic. So what's happening and why cryptography is important, right? One of the major issues with proof of liabilities is, in practice, any exchange, especially if there is no regulation, can say that, hey, I owe to my customers if they all try to withdraw this amount of money, right? And they can state this. Who can audit this, right? I mean, there are particular exchanges that they live in like the restrictions for which there is no auditing system. And then if the users who own these assets on their exchange, right, which are in their books, in an Excel sheet, there is some accounting book, and they know, oh, Kostas has 300 Bitcoin, Aniket has, I don't know, 1,000 Bitcoin, and so on. Joshua has more. How do we ensure that the total amount that they advertise is exactly their whole liabilities for all of their customers? And then there is a whole like sector in cryptography. They're usually called proof of liabilities. And in the background, they're using zero knowledge proofs, or like Merkle trees, where imagine people putting their balances into a leaf of a Merkle tree, like each one has their leaf. And then we go up to the root, and it's not a regular Merkle tree, it's actually a summation Merkle tree. Every single time we go up, we add left and right the leaves, and then eventually you go up to the root, and we have a commitment into a total sum. Now, if you add zero knowledge proof over this, that the construction was literally correct, then what you can do is you can create for the first time a decentralized sampling system, which means that you can provide this top root of the Merkle tree into a blockchain or any public bulletin board. And then if a user like myself, I see, I don't know, one particular company publishing a total amount of liabilities, is my 300 Bitcoin there? Because this is what we do, right? In real life, we have auditors, and the auditors do statistical sampling as well, and they also do some other like checks. But what if there is no such a requirement in the system? Use your users. So every user can actually have like the potential to be able to check at least their own balances included in the total with privacy, right? Because we don't want to reveal our like Bitcoins whenever we're doing this check. And imagine we prove that if only a small percentage of users actually checks their involvement, like their inclusion in this summation, we have 99.9% probability that the exchange is not cheating. So this is when you're implementing all of this correctly. However, I realized when I went to many exchanges that implemented this stuff, they made some mistakes. And the mistakes come from, like, in some particular situations, are silly mistakes. For example, they are truncating the hashes into 8 bytes. And imagine now someone can brute force it, right? I can find another balance that even if you prove inclusion for your 300 Bitcoins, I put 1 Bitcoin there. And then you can never figure out because you verified the inclusion correct. So this was one issue that I identified in some of the major exchanges. You can see my work on the web. And then we realized another issue that they're doing. Some of them were using wrong cryptography, outdated. Many of these protocols were not published in conferences, so they were not peer-reviewed, and they were exchanged in some forums. So some exchanges or the auditors actually grab them, and they use them without extra auditability, like from some cryptographer like Dr. Kate to be the auditor of this particular scheme. And the other thing that we realized was like a mistake is they didn't use the blockchain to publish the commitment. The blockchain, we have to take it into account, right? It's a public bulletin board for a reason. There is one view of what you are publishing. Imagine if the exchange is signing over a root here and another root somewhere else, it sends me the other root and to Dr. Kat another root. And we both verify our involvement correctly, but we're actually verifying inclusion in different commitments, right? So this was also a mistake, and they could always cheat here. And in some particular cases, another issue I realized is all of the platforms, exchanges, typically assign a unique ID to the user, right? However, if the unique ID is what identifies me into the system, if I had 300 Bitcoins and Dr. Kate had 300 Bitcoins, but somehow the exchange used the same user ID for both of us, we will both verify the same $300 in the same commitment. However, it's $600, right? It's 300 and 300. So we're both happy, but because there was never any assurance that like these unique IDs are indeed unique, the exchanges could actually merge all of the balances that are the same. And in some particular cases, this is true. People typically tend to have like rounded values, like 2 Bitcoins. I don't have 1.9 Bitcoin. I buy literally 2 Bitcoins, right? And then they could see it up to 5% or something in some particular application. So we need cryptography. We know zero knowledge proofs and like good accumulators are very important for crypto, but we need good auditing as well. But this is the technology. It exists out there. We know people are doing it in the wrong way, but we're here to solve this problem.
Yeah. Very nice summary, Kostas. So I know that we are coming to the close. So I want to just add one point to it, like extremely, it's very great to hear all the really experience. It can be like you can write a SOK on this topic. So thing I want to add here is that one could be in the future, it could be interesting to also somehow if we can link the reserves as well as liabilities when it comes to the Web2 world. So for example, can we bring the Web2 data also to the Web3 towards in possibly so that many of those Web2 collection could be TLS. So how can we collect that data in a privacy preserving manner is also a very interesting problem. There's a solution like Deco that I've come across in that respect, but there is certainly more that we can do in that respect, and that's certainly a problem that I want to bring attention to. But yeah, I know we have only a couple of minutes left, so I'll leave it up to them. Yeah, thanks, Kostas. Great to hear those stories.
Yeah, that was a very great explanation. Thank you so much. And I want to remind all developers, whether you work at a project, blockchain project or exchange, don't roll your own crypto. Talk to professionals, experts, mathematicians, Dr. Kate, Dr. Kostas, and others, and be vigilant and robust and careful. This is very serious stuff. It's high stakes. So, don't rush, move fast, but do not break things, So, we do have only about a minute and a half left. I do want to see if, just in 1 or 2 minutes, we can just talk about each of you personally, what is one thing that you're really interested in or inspires you about blockchain and the future of blockchain? Maybe a couple sentences each. Maybe we can start with Kostas.
Yeah, imagine my middle name here, Kryptos, is not random. I named my oldest son Kryptos, right? I'm full all in into the cryptography space. I personally work a lot with zero knowledge proofs, and to tell you the truth, I believe it will be the future. It's already the moon math of cryptography, along with succinct accumulators and all of this stuff, like the work that Dr. Kate is doing. But I believe we will see more systems into anonymous credentials, along with zero knowledge proofs, and maybe in the future even fully homomorphic encryption. I want to see it on the blockchain somehow. And this is where I'm focusing these days, along with my team, for new primitives in the space.
Yeah. So starting from where you left off, so I look from the application perspective. All things that you mentioned are related to privacy, and I find the privacy to be an extremely important topic that is understudied from two directions. One, I want to just make a bold statement here. Privacy on blockchains or even in off-chain world is expensive today. Even going beyond 10,000 or 10,000 transactions per second is not possible, so it can't scale. We need solution that can scale here, and that's a technical and cryptography challenge, and possibly we may want to make it scale in the post-quantum world, making things more difficult. But I want to add one more aspect, which is probably even challenging because more human, is the regulation issue. So we need to see more clarity there in terms of how can the privacy and regulation can work in hand in hand. And it certainly is a very important topic that we have to look into, because as more and more people start to use the systems, privacy is going to become an important and crucial factor.
100%. Privacy is a human right, and we won't transact as much as we would if it's just completely all out in the open. And that is a very astute observation that there's kind of two forces. You have privacy and you have these regulations, and they're kind of a little bit at odds with each other, but there will be a happy medium. Well, thank you so much. It was really fantastic. I really love to talk with you guys, absolute geniuses. And thank you so much for attending MoveCon, and we hope to see you soon again. That's the end of our session.
Thank you, Joshua.